Okay, in this video we're going to talk about point slope form, which is another type of, or another way you can write an equation of a line that you can then work on converting it to standard form. So point slope form by definition is a linear equation of a non-vertical line written in the form y minus y1 equals m times x minus x1. Remember, m stands for slope, where m equals slope and x1, y1 is a point on the line. So if you have your point slope form, and this is very important, this is something you need to remember, you have y minus y1 equals m times x minus x1, where m is your slope, and here x1, y1 is a point on the coordinate plane. This y and this x are part of your equation. They're going to fall into y equals mx plus b, which is another equation that we've already learned. So this y is just a variable, this x is just a variable, this y1 and this x1 are actual points you're going to pull off of the coordinate plane, and this m is your slope, which you know how to find, or you could possibly pull it off of the coordinate plane. Okay, so let's say we want to graph using point slope form. So let's say we're going to graph this equation, y minus 5 equals x times x minus 2. So again, look here, here's my y and my x that I said were just variables. Here's this minus 5, this minus 2, which are points on the coordinate plane, and here's my slope. So first, we want to identify the point, the xy point. Okay, so if you remember our equation, let me get a different color. Remember, our generic equation that we dealt with was y minus y1 equals m times x minus x1. So if it's minus here and minus here, then when we take the number out, they will be the opposite. So since it's minus 5 here, then our y coordinate is positive 5. It's minus 2 up here, my y coordinate is positive 2. Okay, so we're going to identify the point and we're going to plot it. So I'm going to go up here and I'm going to go over 2 and up 5. I'm just going to plot that point. Then I'm going to find my slope. Well, remember, m is right here on the outside of the parentheses. My slope was 1/2. So now I'm going to go back to my point and I'm going to plot my slope. Remember, our slope is rise over run. So I go up 1 and over 2 and draw that point. Now I can draw a line to connect my points. Alright, so let's try this next one. So let's identify the point. So remember, I want my point in x, y. So my point, here it says x plus 2. Remember, my formula is minus 2, so that means that my actual point is negative 2. Here it's a minus, so it would be positive 5. Okay, my slope is negative 2/3. Alright, so let's go ahead and plot this point. So I'm going over negative 2, but I'm still going to go up 5. 1, 2, 3, 4, 5. So I'm going to go here. Okay, my slope is negative 2/3. Rise over run, so I'm going to go down 2. I'm going to go down 1, 2. I'm going to go over 3. You always go over to the right. So I'm going over 1, 2, 3. So about right here, I started here. So if I go over 1, 2, 3, I'm right there. Now I can draw my line right here. Okay, and if I check this, let me put a better dot here and here. Remember that my line has negative slope, so it should be going down the mountain. Remember, positive slope climbs up, down. Okay, so that's what this line would look like. Alright, so let's look at the next thing. We want to write the equation that passes through the point negative 1, 7 with a slope of negative 3. So this time we're going backwards. I was giving you the equation in point slope form and asking you to graph it. Well, this time I'm giving you the point, I'm giving you the slope. I want you to take it and put it in the equation using point slope form. So here is my point slope form. So let's go ahead and write it in this form. So we know y minus y1. Well, here's our y1. So y minus 7 equals negative 3. There's our slope. And then we're going to do x minus, what is that, negative 0. Or negative x1. So we're going to get, or this should be a negative, minus a negative 1 is going to give us y minus 7 equals negative 3 x plus 1. Remember, minus and negative ends up being plus. So since the formula says minus and negative, we just write plus. You can put it in the opposite. You can skip this step if you can remember to go straight here. Let's try another one. Write the equation that passes through 10, negative 8, with a slope of 2/5. Here's your equation, y minus negative 8. Again, if you can skip to this to that, that's fine. But know that this and this are the same. So y minus negative 8 equals 2/5. There's your slope. X minus 10. You're going to end up with this. Y plus 8 equals 2/5 times x minus 10. You've got to remember, if you're skipping straight to this, that your formula is actually y minus y1 and x minus x1. Alright? So, using 2 points, write an equation. So in other words, this time you have to start out finding the slope. You know how to find slope. You know this formula. You learned it in 6th grade if you had me. So find your slope, then write your equation. So if these are our 2 points, we're going to find our slope. y2 minus y1, so 5 minus negative 4 over x2 minus x1, negative 3 minus 6. So we get 9 over negative 9, which gives us negative 1. So there's our slope. There's our first point. Remember, this is our equation that we're working with. Okay? Now, you can use either one of the points. You can use this one, you can use this one, but make sure that you're using one x and one y, and not 2 x's and 2 y's. So, use either point. So I'm going to pick, we'll write it both ways. So we can do y minus 5 equals negative 1 times x plus 3, or y plus 4 equals negative 1 times x minus 6. Do we have to write the negative 1? Because I've always saying you don't have to write a 1. If you don't, you do need to write it this way, which looks kind of funny. So in this case, I do want you to write the negative 1. Alright, so let's look at another one. Let's find our slope. So we're going to do 5 minus negative 8 over negative 2 minus 3. So this becomes 5 plus 8, so it's 13 over 5, negative 5. So m equals negative 13 fifths. I'm really glad we don't have to graph this one. Alright, now we're going to use either point and slope to write the equation. So I'm going to start with this one. So I'm going to skip right on to y plus 8. Remember, it would be the same as y minus negative 8. So y plus 8 equals negative 13 fifths times x minus 3. Whoop. X minus 3. Or y minus 5 equals, it's still negative 13 fifths, times, and this time it's going to be x plus 2, because I'm skipping straight there. You don't need both. It's either point. Okay. Very important concept number 1. 2 sets of data have a linear relationship if the rate of change between consecutive pairs of data, there's this word consecutive again, that we've talked about in the past, is the same. The rate of change, or ROC, is the slope. And we know that. We know that slope is consistent as it goes up. Is relationships shown by the data linear? If so, write the equation. Okay, and you need to remember that ROC is equal to slope. So right here, negative 1 to 3 to 5 to 11. Alright, do we have a linear rate of change? So if we found our vertical and horizontal rate of change, we have 2 to 4, which is 1/2. We found our change here, we have 1 to 2, which is 1/2. We have 3 to 6, it's 1/2. So every time you're looking for the vertical change over the horizontal change, or the y over the x, every time it works out to 1/2. So is it linear? Yes. If it's constant, it's linear. So if so, it says write an equation. So again, I can pick 1 point out of these 4 to make my equation. So again, how did I figure out that these were the same? I looked at the rate of change between each number, 4 to 6, 6 to 7, 7 to 10. I came on this side, negative 1 to 3, 3 to 5, 5 to 11. I found the ratio, or the rate of change between them, every time it was 1/2. Because it was the same, I know that this is a linear relationship, or that it's going to form a line when graphed, and therefore I'm able to write this equation. Alright, so let's look at a second one. If I look at the x values here, from negative 4 to 2, it's 6. From 2 to 5, it's 3. From 5 to 9, negative 9, it's 4. That's a lot more than 4. That's okay. 9 to 3 is 12. Negative 6, negative 8. It's negative 12. So here, we have a change of negative 2. The slopes are the same. So once again, we can write our equation. So let's look at one more. So here, 3 to 6 is 3. 6 to 9 is 3. 9 to 15, we have 6. What about here? We have 3. 4 to 13, we have 9. 13 to 49, 6. We have 36. So what's our relationship? 3 over 3 is 1. 9 over 3 is 3. 36 over 6 is 6. So in this case, is it linear? It is not. So we do not have to write an equation. And that is how you use slope in an ordered pair to write an equation.